So very good morning to all of you. Yesterday we have seen the first type of characteristics of thyristor or SCR, wherein we have discussed VI characteristics. Now apart from VI characteristics, we have switching characteristics and gate characteristics for thyristors. And as you know that thyristors and SCR, they are very close to each other. SCR is a family member of a thyristor and has almost all the characteristics of required characteristics of thyristor in SCR. Okay. So the switching characteristics, as you all know that whenever we use any semiconductor device, power semiconductor device, we use it as a switch. So the basic function of any semiconductor device is a switch. Now when we say switch, there are two states possible only. Either switch can be on or it can be off. Okay. Now when we say switch is on, that is a semiconductor device is in the operation. The semiconductor device is in the operation. Means what? Suppose we represent a simple switch like this, and when we say it is on, we have the two terminals of the switch short circuited. Means like this. Okay. And when it is off, we represent it as open circuit. So it is short circuit and it is open circuit. Okay. Now, when we say short circuit, the voltage drop across the switch is almost zero. Voltage drop across switch is almost zero, provided the internal loss due to the material of the switch or anything is negligible. In that case, voltage drop is zero. But current is what? High. Or you may get considerable current through the switch when it is in the on state. That is, it is conducting and it carries the forward current. Yesterday I asked one of the student that what do we mean by forward current? Actually, when we say forward current in case of semiconductor devices, forward current, the meaning is that suppose we have three terminals, anode, cathode and gate. Forward current of any device is current from anode to cathode. That's it. That is also called as working current, forward current. Okay, all meanings are same. Now we get the current, but the voltage is zero. And if we look at the off state of the switch, we know the voltage is high. Whatever the rating of the voltage, rating of that switch, we experience that voltage to be present between these two terminals of the switch. Okay, let us say we are connecting thyristor, so these two terminals must be anode and cathode. Okay, provided there is no current. There is no current. Okay, there is no current. So when any switch operates, it operates in two states. Either it is on or off, and in those states, it represents these characteristics or these features. Now, this is required because we need to study the switching characteristics of a thyristor or SCR or any device. Whenever we are using it as a switch, it will represent these two states. Okay, and we call it as a dynamic characteristic because when we operate switch, we operate with respect to time, and if we plot the nature of these parameters with respect to time, how this parameter responds to the time. Okay, so time is one of the important parameters. So time is a constraint. Okay, so when time is a constraint, we say that is dynamic characteristic. Okay, this is one reason. Okay, and the another reason is that there is a transition when switch is on, from on to off. There is a transition when switch is off, from off to on. There is a transition. So whenever there is a transition in any action or in any process, and if we plot them on a characteristic, if we plot them graphically, then we say dynamic characteristic. That is why these characteristics are also called as dynamic characteristic. The number one reason is that it is associated, or these characteristics are associated with the time, how the parameters like voltage and current, they respond to these actions on and off with respect to time. And number two reason is that there is a transition from on to off or vice versa. Hence, these characteristics are also called as dynamic characteristics. Dynamic characteristics. Okay, and these characteristics are bounded by the time. Okay, there are time limits on these characteristics. You will see how time bonds to these parameters. Time bond is important in these characteristics, how it is. So we are going to see that in detail, and that's why these characteristics are called as dynamic characteristics. But if you look at the VI characteristic, these characteristics are called as static characteristics. Okay, yesterday the characteristics which we have seen, discussed, are static characteristics. Okay, why? There is a no time bond. Voltage or current, there is a no time bond. त्या कॅरेक्टरिस्टिक मध्ये कुठेही आपण टाइमला मेन्शन केलं नाही, परंतु ज्यावेळेस आपण स्विचिंग कॅरेक्टरिस्टिक शिकणार आहे त्यामध्ये आपल्याला टाइम हा एक जो पॅरामीटर आहे त्याला धरून चालायचा आहे. विथ रिस्पेक्ट टू टाइम, हाउ व्होल्टेज अँड करंट दे आर चेंजिंग during the switching operation. Okay, switching in the sense during on and off. So there are two processes are involved, two transitions are involved, on to off and off to on. The process of making transistor on has a different meaning in semiconductor devices, and that process is called as triggering. Okay, the process of making device on is called as triggering. There are different techniques or the methods to make device on. For example, in case of thyristor, we have provided with the gate terminal, and the significance of gate terminal is to make it on only. That is, this gate is for triggering. In case of thyristor, I am talking. This gate is associated with turn on of the semiconductor device. The turn on process is called as triggering, and there are different techniques to turn on. Here, by applying the gate pulse, we are making it on. That is one technique. Another technique is you may not use gate here, even though it is provided. If you are not supposed to use gate, then how will you make it on? We have seen the mode of conduction of the device. In forward blocking mode, we say we are applying forward bias, and if we go on increasing the voltage, the thyristor will get turned on. Means there is considerable current after breakdown of the junction J2. Okay, even though junction breaks down, there is a current from anode to cathode. That is another method. Okay, but that method is not expected. Since we are having gate terminal here, the simple and sophisticated way to turn on the SCR is by providing gate pulse to the gate terminal of the device. That is called as triggering. So any method which is associated to turn on the SCR, to turn on the thyristor, is called as triggering method. We are going to see triggering methods in detail in some other session, but at least at this particular stage you should know what is meaning of triggering. Okay, आता या स्टेजला तुम्हाला ट्रिगरिंग म्हणजे काय कळालं पाहिजे. म्हणजे इथून पुढे ज्यावेळेस तुम्हाला ट्रिगरिंग म्हणजे काय विचारलं जाईल त्यावेळेस तुम्हाला एवढंच माहिती असायला पाहिजे किंवा उत्तर देता आलं पाहिजे की ट्रिगरिंग याचा अर्थ डिव्हाइसला टर्न ऑन करणे. ओके, द प्रोसेस involved to turn on the device is called as triggering. Okay, if we look at the another transition, okay, that is the next state of any device is the off state. Okay, so we need to have turn on as well as turn off. Okay, जशी एखादी कार आपण सुरू करतो, आपण स्टार्ट करतो, तसं कार थांबवणं पण गरजेचं आहे. फक्त सुरूच ठेवणं इम्पॉर्टंट नाहीये किंवा उपयोगाचं नाहीये. कारला थांबवता पण आलं पाहिजे. म्हणजे स्टार्ट आणि स्टॉप आपण असं म्हणतो. जी स्टॉपची प्रोसेस आहे, द प्रोसेस बाय विच वी स्टॉप द डिव्हाइस टू कंडक्ट, that process is called as commutation. So commutation is opposite of triggering. Commutation. So very parallelly, triggering has some methods. Triggering, there are techniques. Also commutation, it has also some techniques, some methods to be adopted to commutate. But it is not compulsory that we should only use gate to commutate the device. For example, in case of SCR, this is something very important. In case of SCR, we use, to turn on the SCR, we use gate terminal. Okay, by providing gate pulse, we are making it on. Okay, that is, we are using gate pulse triggering method to make it on. But I cannot use gate terminal to make it off. What I'm saying has a meaning. What is that? We can use gate terminal to turn on only. We cannot use gate terminal to turn off in case of SCR. This is associated with SCR. In other device you may use gate terminal, but in case of SCR, once the device is turned on, gate loses its control. Once the device is turned on, gate loses its control. Okay, so you need to remember that in case of SCR, gate is used only to turn on, not to turn off. Okay, so commutation technique for SCR are something different. They are not using gate terminal. Okay, so gate has only role to play in triggering, not in commutation in case of SCR. Okay, so these are the basic things which I have explained to you. When we are supposed to draw the switching characteristic, we must know these things associated with the switch. या गोष्टी जर आपल्याला माहिती असतील सेमीकंडक्टर डिव्हाइस बद्दल, तरच आपण त्याच्या स्विचिंग कॅरेक्टरिस्टिक ड्रॉ करणं मीनिंगफुल आहे. आता याला स्विचिंग कॅरेक्टरिस्टिक का म्हणायचं? द रिझन इज दॅट द ऑपरेशन which is related to the switch is called as switching. Okay, now switch has two operations or two states, on and off. When switch is on, we get no voltage but there is a current. When switch is off, we get no current but there is a voltage. The process of making any device on, we call it as a triggering. The process of making any device off, we call it as a commutation. Now why these switching characteristics are called as dynamic characteristic? The number one reason is that these characteristics are associated with time bond. Okay, that is, these characteristics are associated with variation of voltage and current with respect to time. Okay, so there is a time parameter which bonds these characteristics, which limits these characteristics. Okay, and another reason is that there is a transition from on to off and off to on. Means we are moving. Transition means the switch itself is moving from on to off and from off to on. Transition is, the meaning of transition is change in position. Okay, so that in that way also you may call these characteristics to be dynamic characteristics. That is, they may ask, draw the dynamic characteristics of SCR. So you get confused that we have learned VI characteristic, we have learned switching characteristic, gate characteristics as well. But what do you mean by dynamic characteristic? Dynamic characteristics are associated with switching characteristic. Means their meanings are almost same. म्हणजे त्यांनी जर डायनामिक कॅरेक्टरिस्टिक विचारलं तर तुम्हाला स्विचिंग कॅरेक्टरिस्टिकच ड्रॉ करायचे आहे. ओके, तर इथून पुढे ट्रिगरिंगचा अर्थ आणि कम्युटेशनचा अर्थ हे हा कंपल्सरी तुम्हाला इथून पुढे लक्षात ठेवायचा आहे. ट्रिगरिंग मेथड्स म्हणजे टर्न ऑन करायच्या मेथड्स, कम्युटेशन मेथड्स म्हणजे टर्न ऑफ करायच्या मेथड्स. ओके, प्रत्येक एससीआर किंवा प्रत्येक सेमीकंडक्टर डिव्हाइसेसला ट्रिगरिंग मेथड्स आहेत आणि एकच आहेत असं नाही. गेट दिलाय म्हणून गेटनीच डिव्हाइस टर्न ऑन केला पाहिजे असं नाही. तुम्ही करू शकता, परंतु व्हॉट इज सफिशियंट or efficient method to make them on by using gate terminal, that is possible because it is efficient. आणि त्याच्यामध्ये गेटचं सिग्निफिकन्स, गेट हा टर्मिनल असण्याचं काहीतरी मिनिंग पाहिजे त्या ठिकाणी, म्हणून आपण गेट थ्रूच कोणताही डिव्हाइस टर्न ऑन करू शकतो. शिवाय त्याच्यामध्ये आपण प्रोग्रामिंग करू शकतो. पुढे जाऊन तुम्हाला कंट्रोल रेक्टिफायर शिकायचं आहे की ज्याच्यामध्ये तुम्हाला गेटला पल्स द्यायचे ठराविक इन्स्टंटला, आपण त्याला फायरिंग पल्स असं म्हणतो. तर ती फायरिंग पल्स म्हणजे काय, गेट सिग्नल अप्लाय करणं. अँड दॅट फायरिंग पल्स इज टर्म इन टर्म्स ऑफ डिग्री, म्हणजे 30 डिग्रीला टर्न ऑन करायचं, 60 डिग्रीला टर्न ऑन करायचं, 45 डिग्रीला टर्न ऑन करायचं, म्हणजे आणि याचं प्रोग्रामिंग सुद्धा आपल्याला करता येतं. म्हणून द इफिशियंट अँड sophisticated way to turn any device on is by using gate terminal. Okay, that again we are going to discuss in detail in few sessions. Okay, so that is all about the switching characteristic. The fundamental concepts I have explained it to you, and it doesn't mean that the switching characteristic means we need to write something, we need to write all those things, not required. Switching characteristic, only you should draw the characteristic and explain each and every parameter term present in that associated with that switching characteristic. म्हणजे जर तुम्हाला स्विचिंग कॅरेक्टरिस्टिक जर विचारला एक्झाम मध्ये, तर त्या केस मध्ये तुम्हाला हे सगळं द्यायचं आहे असं नाही. स्विचिंग कॅरेक्टरिस्टिक काय असतात हे तुम्हाला कळावं, समजावं, याच्यासाठी हे मी त्याचं फंडामेंटल एक्सप्लेन केलेलं आहे. प्रीरिक्विजिट त्याचं मी एक्सप्लेन केलेलं आहे. हे तुम्हाला एक्झाम मध्ये एक्सप्लेन करायलाच पाहिजे असं नाही, परंतु अंडरस्टँडिंग साठी हे मी तुम्हाला सांगितलेलं आहे. मग स्विचिंग कॅरेक्टरिस्टिक म्हणजे काय किंवा कशा ड्रॉ करायच्या, त्याच्याशी असोसिएटेड असणारे पॅरामीटर्स कुठले आहेत आणि ते डिफाईन कसे करायचे. तत्पूर्वी हे फंडामेंटल प्लस हे अगोदर सांगितलंय तेच परत एकदा पण लक्षात ठेवा. काय, दिस इज द टाइम व्हेरिएशन. टाइम व्हेरिएशन, switching characteristic is a time variation of what? Current. Important parameter is current. कारण कोणताही डिव्हाइस ऑन आहे म्हणजे काय प्रेझेंट आहे, करंट. म्हणजे तसं बघायला गेलं तर व्होल्टेजला कमी प्रायोरिटी आहे, करंटला जास्त प्रायोरिटी आहे. कोणताही डिव्हाइस टर्न ऑन कधी होतो, जर करंट फ्लो झाला तर. ओके, व्होल्टेज काय कुठल्याही दोन टर्मिनल मध्ये असू शकतो, परंतु करंट हा कुठल्याही दोन टर्मिनल मध्ये येईलच असं नाही, त्याला कंडिशन्स असतात. म्हणून करंटला जास्त प्रायोरिटी आहे आणि मग व्होल्टेज आहे. ओके, टाइम व्हेरिएशन ऑफ करंट and time variation of voltage, but highest priority should be given to the current, because working current, forward current, when we are expecting from a device when it is only turn on, when it is in the operation. Voltage can be present when it is turn off, doesn't matter. Okay, but what is important is working current, forward current, anode to cathode current, anode current meanings are same. Okay, so that current we are expecting here. And for that you must remember that the variation of current with respect to time, variation of voltage with respect to time are nothing but the switching characteristic of any device. Okay, so this is the basic fundamental regarding the switching characteristic. Okay, so we will see how these characteristics can be drawn and how these characteristics can be plotted. Okay, so I am supposed to turn off my video now, and then I will share the screen. So we are going to switch to the presentation. Okay, so before that, if there any problem त्याच्यामध्ये आतापर्यंत जे काय झालेलं आहे, काय सांगितलेलं आहे, काय समजलेलं नाही, किंवा कन्फ्युजन आहे, किंवा वेगळं काहीतरी सांगितलेलं आहे, चुकीचं काहीतरी सांगितलेलं आहे, असं काय असेल तर प्लीज लेट मी नो. If the audio is clear, ऑडिओ क्लिअर आहे का?
येस सर.
ओके. प्रेझेंटेशन मध्ये कोर्स कोड जुना कोर्स कोड आहे. सो डू नॉट गेट कन्फ्यूज बिकॉज दिस इज फर्स्ट रिव्हिजन. ओके. And I have not changed in my presentation those codes. I'll let it, I'll get it changed. So SCR characteristics. As we all know that there are three type of characteristics associated with SCR: VI characteristic and switching characteristic, as well as gate characteristic. Now switching characteristic. The time variation of the voltage across SCR and the current through it during turn on and turn off constitute the switching characteristic for SCR. Now, how SCR produces the switching characteristic, or how we can get the switching characteristic from the device? It is the time variation, as I mentioned, time variation of what? The voltage and the current. And in my opinion, current should be given highest priority. Okay, so turn on and turn off. Turn on in the sense we get the current, turn off in the sense we get the voltage. Okay, so this switching characteristic can be drawn. During turn on and turn off process, SCR is subjected to different voltages across it and different current through it. Okay, so it's not that we directly will get the rated current and rated voltage during turn on and turn off process. Ideally we should get the rated voltage and rated current. समजा एखाद्या स्विचला ऑन आणि ऑफ करण्यामुळे आपण जो काही लोड लावलेला आहे सप्लाय साठी, म्हणजे थोडक्यात सोर्स आणि लोड यांच्यामध्ये काय येतो तर स्विच येतो, आणि डिरेक्टली आपण स्विच ऑन आणि ऑफ करण्यामुळे लोडला जेवढा एक्सपेक्टेड करंट रेटिंग आहे समजा त्याचं 5 एम्पियर, इन्स्टंटली लगेच 5 एम्पियर होईलच नाही. जर आपण त्यात सेमीकंडक्टर डिव्हाइसेस वापरत असू स्विच म्हणून, तर एखादा स्विच जर सेमीकंडक्टर डिव्हाइस असेल तर त्याला जर आपण ऑन केला तर डिरेक्टली आपल्याला 5 एम्पियर करंट मिळेल असं नसतं. दॅट करंट विल इन्क्रीज and decrease gradually, but ideally it should be 5 ampere. It should deliver like 5 ampere, but that is ideal condition, and we know that the ideal condition doesn't exist. Okay, practically हे possible नाहीये. Ideal काय आहे की आपल्याला सडनली 5 ampere मिळायला पाहिजे असं आपण म्हणतोय, पण आपण म्हणून काय होतंय का नाही. याचा अर्थ प्रॅक्टिकली त्याच्यामध्ये काहीतरी इश्यू आहे आणि तो इश्यू आपण ट्रान्झिशन्सच्या मीडियम मधून स्विचिंग कॅरेक्टरिस्टिक वरती ज्यावेळेस प्लॉट करतो त्यावेळेस आपल्याला ज्या कॅरेक्टरिस्टिक मिळतात त्या म्हणजे स्विचिंग कॅरेक्टरिस्टिक्स. ओके ओके. म्हणजे याचा अर्थ काय होतो की व्होल्टेज आणि करंटचं व्हेरिएशन होतं आपण ज्यावेळेस टर्न ऑन आणि टर्न ऑफ करतो त्यावेळेस. पुढे जाऊन तुम्हाला स्विचिंग सर्ज नावाचा कन्सेप्ट येणार आहे हाय व्होल्टेज इंजिनिअरिंग मध्ये किंवा पुढे फायनल इयरला असेल किंवा कुठल्याही पॉवर सिस्टीम रिलेटेड हा इश्यू आहे. स्विचिंग सर्ज मध्ये काय असतं की त्यावेळेस ऑन आणि ऑफ किंवा ऑफ आणि ऑन यांच्यामध्ये ट्रान्झिशन होत असतं त्यावेळेस आपल्याला करंटचा स्पाइक भेटतो की जो हार्मफुल आहे लोडसाठी जो आपण त्याला जोडलेला आहे. दॅट स्पाइक इज कॉल्ड एज स्विचिंग सर्ज. तो सर्ज कशामुळे येतोय तर स्विचिंगमुळे. Switching transients, they are called as switching transients because of which the harmonics are present, harmonics are generated, and due to the harmonics there are losses. So those concepts you will learn in future, but those concepts are associated with the switching operation. Okay, for now you should remember this only. Now this is how the characteristics are plotted. Okay, now you see that how the current is changing with respect to time. In the first characteristic, which is the anode voltage with respect to time, and the second characteristics are anode current with respect to time. Now anode current or uh, anode current, the meaning is forward current, the meaning is current of that device. Okay, the actual current you can call it as. Okay? So how that voltage and current changes with respect to time. And you know, I already have explained it to you that ideally when we say switch is on, the voltage is 0. When switch is on, the current is the expected means device current. Okay, and okay. So for any device voltage and current, how they are changing with respect to each other. It's not that they will change independently. Okay, if the current is high, voltage must be low. If the voltage is high, current must be if the voltage is high, current must be low. If the voltage is low, current must be high, like that. Okay, and that is very reflected in the characteristic. And both parameters, both the quantities, they are changing with respect to time, as I mentioned earlier. Okay, so there is variation. Next. Now I'm expecting you to draw this. Okay, and later on I will switch to the next. Okay, so you can take your time. You have to draw it carefully because you can see that the relations are shown, like the voltage is at its maximum value, then it is changing at 0.9% of its maximum value, means 90% of its maximum value, then 10% of its maximum value, and suddenly what happens with the current? For example, in voltage variation with respect to time, when current is at its voltage is at its 90% of maximum, the current is at its 10% of its maximum. Okay, so this relation has to be maintained. So there is a projection, 90% of voltage to 10% of current. So you need you are supposed to draw these characteristics very neatly and carefully. These projections should match. म्हणजे ज्या इन्स्टंटला व्होल्टेज 90% असतं त्याच्या मॅक्सिमम व्हॅल्यूच्या त्या इन्स्टंटला एनोड करंट हा 10% असतो सेम इन्स्टंट आहे. ओके, लेट अस से T1, समजा T1 ला 90% करंट व्होल्टेज त्याच्या मॅक्सिमम व्हॅल्यूच्या आहे, तर त्याच वेळेस करंट हा 10% असतो. हे रिलेशन मेंटेन करावं लागतं ज्यावेळेस आपल्याला स्विचिंग कॅरेक्टरिस्टिक ड्रॉ करायच्या आहेत त्यावेळेस. फक्त या कॅरेक्टरिस्टिक ड्रॉ करायला समजा असं विचारलं असेल, एक्सप्लेन दी स्विचिंग कॅरेक्टरिस्टिक ऑफ थॅरिस्टर or SCR. Okay, and if the weightage is 8 marks or 6 marks, then 50% weightage is to draw these diagrams and to mention these parameters correctly on the diagram itself, on the waveform itself. या कॅरेक्टरिस्टिक्स वरती तुम्हाला हे जे सगळे पॅरामीटर्स आहेत तिथंच मेन्शन करायचे, म्हणजे यालाच फक्त हाफ वेटेज दिलं जातं. बाकी उरलेलं जे तुम्ही एक्सप्लेन करता याच्यातल्या टर्म्स आहेत, जसं की टर्न ऑफ टाइम म्हणजे काय, कम्युटेशन टाइम म्हणजे काय, या सगळ्या ज्या एक्सप्लेनेशन तुम्ही देता त्याला हाफ वेटेज, म्हणजे या डायग्रामला खूप इम्पॉर्टन्स आहे. ओके, आणि याच्यावरून तुम्ही एक्सप्लेन करू शकता. कोणतीही टर्म जर तुम्हाला डिफाईन करायला विचारली तर या कॅरेक्टरिस्टिक वरून तुम्ही ती टर्म डिफाईन करू शकता इझिली. ओके, so what I'm trying to say here is you need to draw these characteristics very carefully. You need to mention each and every parameter on the characteristics itself. Okay, that is something very important. अदरवाइज बऱ्याच वेळेस असं होतं की कॅरेक्टरिस्टिक ड्रॉ केलेले आहेत, काहीतरी दिसते, लाईन मोडलेली आहे, कर्व दाखवलेले आहेत, परंतु तिथं काय आहे, कुठला पॅरामीटर एक्सपेक्टेड आहे. जसं की हे रिलेशन जर तुम्ही असं नाही दाखवलं 0.9 VA is associated with 0.1 IA, there is no meaning actually to draw this characteristic. Anybody can draw anything, but you should correlate it with everything which what you are doing. Okay, that is important. So draw it carefully. And as I mentioned earlier that I will ask anytime anybody to turn on their video and show me the characteristics which you have drawn during session itself. Okay, so you'll say that I'll take screenshot and I will draw it later on, or I will draw it directly in exam. It will not do. Okay, next. So to turn on switching characteristic means characteristics have two parts: turn on and turn off. So you may call the first part to be turn on switching characteristic. Okay. The forward biased SCR is turned on by applying positive gate voltage between the gate and cathode. So as I mentioned, the sophisticated way to turn on the SCR is by applying gate pulse. So where that gate is connected along with the cathode. So when gate circuit is expected, it involves cathode. So we should not connect gate and anode together. That is one more requirement of the this switching characteristic or BI characteristic. Whenever we have to connect the gate should be connected in along with the cathode circuit. So gate and cathode they will form one circuit, and anode and cathode they will form another circuit. So there are two circuits in SCR for its operation. Okay, so gate is provided with the gate pulse, and as shown in figure, there is transition time T on. So when we make it on, it will take some time. As you have drawn the waveform, you should observe the waveform when I'm explaining it to you, or when you are reading through the slides. You should observe the characteristics which you have drawn. Okay, so as shown in figure, there is a transition time T on from forward off state to forward on state. So it will require some time to make it happen from off state to on state. Okay, so this transition time is called as the SCR turn on time and can be divided into three separate intervals. That is, turn on time of SCR has three components. Number one, delay time. Number two, rise time. And number three, spread time. So all these three components constitute together the time interval of turn on of SCR. Okay, म्हणजे SCR टर्न ऑन होण्यासाठी काहीतरी वेळ लागतो ऑफ कडून ऑन होण्यासाठी. त्यावेळेस आपण म्हणतो की त्याला ऑन झाला, बरोबर. आणि हा जो टाइम आहे तो तीन कंपोनंट मध्ये डिवाइड केलेला आहे. तीन कंपोनंट कुठले? पहिला आहे डिले टाइम, दुसरा आहे राइज टाइम आणि तिसरा आहे स्प्रेड टाइम. आता इथं एक गोष्ट महत्वाची आहे, हे तीन टाइम इंटरवल डिफाइन करत असताना मी तुम्हाला सांगितलं की व्हॉट इज दॅट 0.9 ऑफ 0.90% sorry 90% of maximum value of the anode current or 90% of maximum value of the voltage. What do you mean by that? Now these terms आर असोसिएटेड विथ दोज रिलेशन्स. डिले टाइम म्हणजे कुठल्या दोन स्पेसिफिक टाइम इंटरव्हल मधला हा डिले आहे, दॅट इज डिले टाइम. राईज टाइम म्हणजे राईज टाइम मध्ये नक्की एनोड करंट कुठून कुठपर्यंत वाढतो, डिले टाइम मध्ये नक्की काय होतं करंट बद्दल, आणि स्प्रेड टाइम म्हणजे करंट स्प्रेड होतो अक्रॉस दी डिव्हाइस, त्याला म्हणायचं स्प्रेड. तर तो कुठून कुठपर्यंत असतो. सो टर्न ऑन टाइम हॅज 3 components: delay time, rise time and spread time. So it is known shortly as TD, TR and TP. Okay, so turn on switching characteristic. Okay, it has 3 time intervals. Delay time, it is measured from the instant of application of the gate current to the instant when the anode current rises from 10% of its final value, or the anode to cathode voltage falls to 90% of its initial value. I hope you are observing the waveforms while reading these definitions of the terms. Okay, then and then only you can understand. It is measured from the instant of application of the gate pulse, the moment at which the gate pulse is applied, that instant, and the instant when the anode current rises to its 10% value. Means initially the current must be zero if it is in off state. The moment gate pulse is applied, the current will start to build across the device. But how it will build? It will build from 0 to 10%. So initially, so that initial interval is nothing but the delay time. Okay, that delay time indicates there is existence of a capability of a device to conduct, existence of a current. That existence can be noted when it rises from 0 to 10%. Okay, now actually from 10% to 90% current increases. That time interval is called as rise time. So for resistive load, rise time, it is the time taken by anode current to rise from its 10%. Now up to 10% we got the delay. From 10% onwards to 90% of its maximum value, we say there is a current increase. We say rise in a current. So that is rise time. So at the same time, the voltage across anode to cathode falls from its 90% to 10% of its maximum value. That is what is happening with the current. Exactly reverse happens with the voltage. Okay, that is when current increases from 10% to 90% of its maximum value. Simultaneously, the voltage decreases from 90% to 10% of its maximum value. So current increases and voltage decreases. But since current is expected, that time interval is called as rise time because current is increasing. Okay, and what about spread time? It is the time taken by anode current to rise from its 90% of its final value to 100%. Okay, we say 5 ampere. So 90% of 5 ampere is 4.5. So when current increases from 4.5 to 5 ampere, that time is called as spread time. And in that interval, actually, we get the expected or ideal current, what we are expecting from that device. आपण म्हणतो की 5 ampere चा स्विच आहे. ठीक आहे, तर आपल्याला जेव्हा 5 एम्पियर एक्झॅक्टली मिळतं त्यावेळेस काय म्हणतो आपण, तो त्यावेळेस तो नॉर्मल ऑपरेट करतो. म्हणजे काय होतं की थोडक्यात जो एनोड करंट असतो तो स्प्रेड होतो ऑल ओव्हर द डिव्हाइस, ऑल ओव्हर द स्विच, अँड वी कुड गेट द कॉन्स्टंट करंट. बट इन दॅट इंटरवल द ऍक्च्युअल करंट इंक्रीजेस फ्रॉम इट्स 90% टू 100%. दॅट इज मॅक्सिमम व्हॅल्यू. ओके, दॅट इज 0.9 IA to IA. IA means 100% and 0.9 IA means 90% of its maximum value. Okay, so actual in that interval current spreads all over the switch. Okay, so these three terms, these three intervals together are nothing but the on time. So you can say T on is equals to TD plus TR plus TP. Okay, spread time plus rise time plus delay time is equals to on time for any AC. Okay, so this is what you can by part it, the switching characteristic. Switching characteristic चा हा पार्ट इथे दाखवलेला आहे ज्याच्यामध्ये फक्त टर्न ऑन स्विचिंग कॅरेक्टरिस्टिक तुम्हाला दिसत आहे. ओके, So we have time, no time left. So I will call your roll numbers, take attendance, and we should stop. Okay? Just